Okay, 1, 2 is called functions. So this continues on with a bit of Algebra 2 review. And then we end with something called difference quotient, which is probably new to everybody in this room. We're going to just touch on functions now. And then the next section we get to graphing them. So we start the definition of a function, which is a rule that assigns to each element x in set A exactly one element y. Which means that no x can be repeated with a different y. You can have the same x repeat with the same y, but you cannot have the same x repeat with a different y. When you're looking at an equation to evaluate if it's a function, it would not be a function if the y is raised to an even power or if it's in absolute value. So eventually we will get to 3 tests to know if something's a function. We will look at points, we'll look at equation, and then eventually we're going to look at a graph. But today we're going to focus first 2, which is what example 1 is. Example 1 just says determine if the relation is a function. So I'm looking at my x values first, okay? If an x is repeated, then I worry about my y values. But if you look at A, are any of the x's repeated? No, which means that this is a function. I don't even have to worry about my y's. Then I go to B, and I look at all of my x values. Are any of them repeated? Yes. Now I go to the ones that are repeated, and I compare the y values. If they're the same, I'm fine. If they're different, then it's a no. So are these different? Which means that this is not a function. Cannot have the same x with a different y. Then we get to equations. So the answer is yes, unless what 2 cases, which was on the last slide? Y can't be raised to an even power or an absolute value. So if you look at C, is y raised to an even power or an absolute value? Nope, so this is a function. If you look at D, is y raised to an even power or an absolute value? Yes, so this is not a function. And E, function or not a function? Not a function. Straight memorization on those things. You're not going to want to graph them and figure it out. Mary Angel.
Wait, why was the first one a function?
Because you can't have an x repeat with a different y. So the y's can repeat, but the x's cannot repeat with a different y. So we looked at all the x's. There was none that were repeated. All right, then we get to evaluating a function. These are big on standardized tests. This is your f of things, okay? F of 2, f of a, stuff like that. All you have to do is take the value that's inside the parentheses and plug it into the variable that's in your original equation. Those look like these. So it'll say evaluate the function at the indicated value. If you look at the first one, A says f of -3. So because inside the parentheses here is your x, that's the variable you're replacing. I'm going to take this 3, -3. I'm going to plug it into the x squared. So I get -3 squared minus 1. And be careful when you're plugging in, make sure you're keeping it in parentheses because that is different than if I don't have parentheses. So what's -3 squared? 9. 9 minus 1 is 8. So f of 3, or -3, sorry, equals 8. Easy stuff, right? Then you go to B. B says f of 2. So now I'm taking 2 and plugging it in. And I get 3. F of 2 equals 3. Then I get to C, which is an expression. It says f of a of plus 2. So I'm going to take a plus 2 this time, and I'm going to plug it in to the x. So I get x plus 2 squared minus 1. Is x plus 2 squared the same thing as x squared plus 4? Is that what I do with that? No, for the love of God, do not do that. Okay, what do you have to do there? Expand it and FOIL it. So this is x plus 2 times x plus 2 minus 1 x squared plus 2x plus 2x plus 4 minus 1 x squared plus 4x plus 3. Yep.
Didn't you say like you can have like even squares or something?
Oh, they should be a's. I'm just kidding. You say what? No, that's if it is a function. The y can't be squared. Those should all be a's. The x can be squared. The x can be an absolute value. The y cannot be. Does that make sense? Right? Look at this. That's the x squared, not a y. Right? X can be squared. Y cannot be.
Like there's like parabolas that
A piecewise defined function is defined as a function that changes based on different values. So you're going to get multiple parts. It's going to say f of x equals this if x is this value. This if x falls in this value. And so the first thing you have to do is determine which range it falls in, and then from there select which of the expressions you'd plug into. They look like this. It says evaluate the piecewise function defined at indicated values. So notice that this is piecewise because there's more than one option. It says f of x is x squared if x is less than 0, and f of x is x squared plus 2 if x is greater than or equal to 0. So the first thing you have to do is figure out if what's in the parentheses falls in which one, which if it's -2, which am I using? The first one, I'm going to plug -2 in there. I get -2 squared, which is 4. Then I go to the next one, and it says 0. Is 0 less than 0 or greater than or equal to 0? Greater than or equal, so I'm using the second one. 0 squared plus 2, which is 2. And the last one says f of 3. Am I using the top one or the bottom one? Bottom. So I'd get 3 squared plus 2, 9 plus 2, which is 11. Easy stuff, right? Eventually we'll graph them and you'll learn that's a little bit more complicated, but for right now we're just plugging in. Okay, then comes solving a function so that f of x equals 0. So it says find the values of the function such that f of x equals 0. And I gave you the hint, obviously, set the equation equal to 0 and solve. That always won't be there. So if I'm replacing, because this is saying f of x equals 0, I'm replacing the entire f of x with the 0. That's why these are different. I'm not plugging in here. I'm going to say that 0 equals 14 minus 2x, and then I'm going to solve it like I would normally solve any equation. I'm going to add the 2x to the other side, or subtract the 14, it doesn't matter. And then divide by 2, and I get x is 7. So you're replacing f of x for the value that they're telling you it is, which in this case is 0, and then you're solving. I go to b, I get 0 equals x squared minus 5x minus 14. How do you solve that? Factor it. As soon as you see x squared and x, no, you're going to have to factor, right? So I'm looking for the factors of negative 14 that sum to negative 5, which would be what? Good. Negative 7, positive 2. Split these and solve them. So x could be 0 or x could be negative 2. And the last one, 0, would equal x squared minus 2x minus 2x squared minus 2x plus 4 over 5. So how do I start that? Oh, thank you. What's the first step? Marion. Before you get there. Get rid of the 5, right? So multiply the 5 on both sides so it's gone. And I get 0 equals x to the third. minus 2x squared minus 2x plus 4. What do you do when there's 4 terms? Group. Factor by grouping. So from the first set of parentheses, you can take out what? X squared. And from the second one, what can go into both negative 2x and 4? 2. If I make it positive 2, because I heard that if I make it positive 2, the signs don't match. So I want to make it negative 2. Because what I want to happen is what's inside these parentheses to be the same term. And then I take that term out. So x minus 2. And group together what's at left, x squared minus 2. Solve by setting them each equal to 0. And I get x equals 2 here. X squared equals 2. So what do I do there? Square root. What do you got to remember to do when you square root? Good. Plus and minus. Square root of 2. So there's 3 answers this time. Negative root 2, positive root 2, and 2.
Answers are based on like the x value. Like if there's x cubed, then there would be
Unless you have a repeated root, but yes. Or there's an imaginary root.
Okay.
Yeah. You'll see when you get to WebAssign. I think some of these are multiple choice, but they might say like, what are the values of x? Put them in order of smallest to largest to make sure like the smallest one goes first. Just pay attention to instructions like that so you get those answers right and you don't get frustrated. The other thing is if you know that like factoring is not your thing and factoring is something that you struggle with, remember that on the iTunes U course there's a ton of supplemental material. If you go to this chapter on the iTunes U course, there's videos, there's extra practice worksheets, there's tons of stuff to help you with factoring. So just make sure that if you know that that's where you're struggling, obviously expect you to know it. I'm not going to teach you how to factor. You got to make sure that you use those resources. Okay, questions on f of x equals 0. Okay, then we get to equivalent functions. What does equivalent mean? Equal. So if you have 2 equations and then you just want to set them equal to each other. For what values of x would they be equivalent? You would just set them equal to each other. And that will look like that. Find the values of x for which f of x is equal to g of x. So I've got f of x is x squared, g of x is 2x plus 8. I just set them equal to each other. And then what? Good. As soon as you see a squared and an x, it should be your indication that you're going to have to solve. Or a cube and x, whatever it is. So you want to get everything to one side so it's set equal to 0, and then you can factor and solve. So I'd get x squared minus 2x minus 8 equals 0. And then I'm looking for the factors of negative 8 that sum to negative 2, which are negative 4, positive 2. Set them equal to each other. X would equal 4 and negative 2. So there are 2 values of x that would make these equations equivalent. Okay, domain. So domain is something you're going to see a lot this year. Domain is the values that you can plug in for x. The default domain is all real numbers with the exceptions of these 3 cases. The first case, if there's a variable in the denominator. If that happens, then you want to set the denominator not equal to 0. Because what happens if the denominator is 0? It's undefined, okay? The second case is if there's a variable under a square root. And for that case, you want to set whatever's under the square root, not the square root itself, but whatever's under the square root, greater than or equal to 0. Because what happens if you try to square root a negative number? You get an imaginary number, right? Which at this point, you're not even pretending like you know them, that we're only dealing with real numbers. The third is the combination of the two. There's a square root, or there's a variable under a square root, variable under a square root in the denominator, and that's the combination of the two. So you're going to take what's in the denominator underneath the root, and you're going to set it greater than 0. So notice the difference here. Because it's in the denominator, it can't equal 0. It still has to be greater than it because it's under a square root. But now if it's in the denominator, it can't equal it. Okay, so those questions will look something like this. It just says find the domain of the function. So if, again, you're looking at 3 cases. If there's a variable in the denominator, if there's a variable under a square root, if there's a variable under the square root in the denominator. If none of those 3 things happen, then it's all real numbers. So if I had something that just said like f of x equals 2x plus 1, this is all real numbers, okay? But if I look at A, what's happening there that I have to worry about? There's a variable in the denominator. So what do I do? Good. Set the whole expression in my denominator not equal to 0 and then solve it. So x cannot equal -1. Now on your test, that answer written that way is fine for me. On WebAssign, it will say all real numbers except -1. And I think most of those questions are multiple choice, so hopefully that's pretty straightforward. I would take either format on the answer when it comes to your test, okay? Look at B. Square root of x plus 3. What's wrong with this one? Or why is it not all real numbers? Something under the square root. So I set whatever's underneath the square root greater than or equal to 0. So I'm ignoring the square root because the square root is not the problem. It's what's underneath it. That has to be restricted. So I would get x has to be greater than or equal to -3. And again, test answer, it's fine like that. WebAssign is going to say all real numbers greater than or equal to, so be careful because it's got to be or equal to -3. Still with me? Yeah? Okay, then I go to C. What's happening here? Is the variable in the top a problem? No, I can have 0 on the top. It's still 0, right? That's an answer. The problem is the variable in the bottom. It's because it's in the bottom and under the root. I'm going to say it has to be greater than 0, not greater than or equal to. So x has to be greater than -4. Again, I can leave the answer like that on a test. On your WebAssign, it's going to be multiple choice, and it's going to say all real numbers greater than -4. And then look at D. So what's happening here? There's 2 things happening, right? There's a square root in the top and there's a square root in the bottom. So I have to say that the top has to be greater than or equal to 0, which means x has to be greater than or equal to -4. And there's a restriction on the bottom that says that 2x plus 1 has to be greater than 0. It can't equal 0 anymore. So I'd get 2x has to be greater than -1 and x has to be greater than -1/2. Now both of these have to be true. So you basically have to figure out which is the more restricted one, okay? If you need a visual on it, like if you want to draw yourself a little number line and try to figure it out, the first one says it's got to be greater than or equal to -4. So it's from this point all the way to the right. The second one says it has to be greater than -1/2. So it's this one all the way to the right. Because it's got to be good for both, what do I pick? The 1/2, okay? If I pick something within this range, it works for the top, but it will still give me a negative on the bottom, and I can't do it. So it's the most restricted one. Sometimes it's the top and sometimes it's the bottom. So you got to pay attention. Questions on domain. You're going to see domain a lot this year. In functions, in graphs, all that good stuff. In composition of functions. Okay, we end with difference quotient. So the difference quotient is probably new for everybody. Okay, hopefully the rest of that stuff you had somewhat seen before. But difference quotient is f of x plus h minus f of x over h. So this is a formula you need to memorize. Okay? And it looks a heck of a lot more complicated than it is. Okay? You just do it in steps. So the first thing we're going to find is f of x plus h. They're going to give you an f of x. You're going to find f of x plus h. Then you're going to subtract from it your original f of x. And then the last thing you're going to do is put it all over h and simplify it as much as you can. Okay? Your notes change at this point, so I want you to kind of disregard that next slide, right? It's different. Yep. Or you can actually just erase or cross out the first find, because we're not going to break it apart on different slides. We're going to do it all together. So the instructions would say evaluate the difference quotient given that f of x equals x squared minus 2x minus 5. So this is your f of x, this whole thing, okay? And what we need to find is f of x plus h. Then we need to subtract from it f of x. Then we need to put it all over h. So start with f of x plus h. If I just said find f of x plus h, what would you do?
Just copy that.
But replace your x's with what? X plus h. So everywhere there's an x goes the x plus h. So this is going to say x plus h squared minus 2 times x plus h minus 5. You with me so far? Then I'm going to expand and FOIL that out. So this is x plus h times x plus h. I'm going to distribute the negative 2. So minus 2x minus 2h minus 5. FOIL that out. X squared plus xh plus xh plus h squared minus 2x minus 2h minus 5. And combine my like terms. X squared plus 2xh plus h squared minus 2x minus 2h minus 5. That whole thing is f of x plus h. You with me so far? Now I have to subtract from it f of x. What's f of x? This whole thing, x squared minus 2x minus 5. So my original function is my f of x. I'm going to distribute that negative. So x squared plus 2xh plus h squared minus 2x. It's okay. All right, minus 2x minus 2h minus 5 minus x squared plus 2x plus 5. So that negative is changing the sign on everything that was in my original function. Be really careful there. That's probably the mistake people make the most, is the signs. Now I'm going to combine my like terms. So I've got a positive x squared and a negative x squared. I've got a negative 2x and a positive 2x. And I've got a negative 5 and a positive 5. So what's left is 2xh plus h squared minus 2h. What's the last part of the difference quotient? Over h. So I'm going to take and put everything I just wrote over h. And then what? Yep, you can simplify. So every term there has an h. Only if every term has the h can you simplify. So h is going to cancel with this one. There's 2 there, and it's gone from there. And I get 2x plus h minus 2. So it will be more or less complex depending on what the f of x is, okay? Like one of the ones in the homework is like 2x minus 3. So it's super easy because you're just plugging it into there. One of them is like x cubed. So it ups it a little bit, okay? You just got to go step by step. My advice is figure out what f of x plus h is. Then take that, subtract whatever f of x is, change your signs, then put it over h. You should always be able to cancel something out once you subtract the f of x. It should simplify to something pretty basic at the end, okay? Not necessarily always this, but something. And just be really careful with your signs because people make the most mistakes with that stuff. Questions on anything function or different quotient related?